How do oscilloscopes work? Breaking news in the world of electrical engineering. The question on many minds today is, how do oscilloscopes work? With technology advancing rapidly, understanding this tool is more important than ever for engineers and hobbyists alike. If you are curious about how these devices visualize electrical signals, you are in the right place. Let's break down the details to help you grasp this essential instrument. An oscilloscope is an electronic device that allows users to visualize and analyze electrical signals. It displays voltage changes over time on a screen, providing a clear representation of signal behavior. When you connect a signal to the oscilloscope, it converts that electrical signal into a visual waveform. This waveform shows how the voltage varies, making it easier to observe characteristics like amplitude and frequency. The main components of an oscilloscope include an input stage, vertical amplifier, horizontal sweep generator, and display system. When a signal is applied, it first goes through the vertical amplifier. This component adjusts the signal amplitude so it fits within the display range. Meanwhile, the horizontal sweep generator creates a time-based signal. This signal moves the electron beam or digital trace across the screen from left to right, representing the time axis. By combining the vertical voltage axis and the horizontal time axis, the oscilloscope can plot voltage against time, forming the waveform. In analog oscilloscopes, this is achieved by directing an electron beam onto a phosphor-coated screen. The beam's position is controlled by the input signal voltage and the sweep signal. Digital oscilloscopes, on the other hand, sample the input signal at high speeds using an analog to digital converter. They then reconstruct the waveform and display it on a digital screen. Modern digital oscilloscopes are equipped with multiple input channels, high bandwidth, and fast sampling rates, often in the gigasamples per second range. This allows for detailed analysis of complex signals. Many of these devices also include digital signal processing capabilities, such as fast Fourier transform, enabling users to analyze frequency components of signals. This feature is particularly useful in advanced research applications, where oscilloscope data is processed digitally for improved signal analysis. In summary, oscilloscopes capture electrical signals, amplify and time them, and display the resulting waveform. This visual representation is essential for troubleshooting and analyzing electrical circuits, making oscilloscopes indispensable tools in electrical engineering.